Okay, in this video we're going to talk about the square root function, and we're going to take a look at its graph and also some of its characteristics. So to come up with the square root function, we start with the quadratic function, y equals x squared, which we've seen before. And what we're going to do is we're going to take the inverse, we're going to find the inverse of the quadratic function. And to find the inverse of a function, you take it and you reflect it across the line y equals x. So if I take this function here, this kind of U-shaped function, and if I reflect it across this diagonal line y equals x, then I'm going to get something, let's see, take a few points here. Each one of these points I kind of reflect across this line. And let's see, each one of these points are going to come over here. I'm going to get something that looks like that. So I kind of start out with a right side up U, and after I reflect it across the line y equals x, I get this kind of sideways looking U. And this is what the graph of the square root function looks like. And now you notice in your notes it says, do you notice a problem with this new function that I've created? And one of the problems that I notice is that, well, if this sideways looking U, if that's supposed to be a function, well, yeah, then I can see I do have a problem because it doesn't pass the vertical line test. So that's a problem. It doesn't pass the vertical line test. And as we know, if we have a graph that doesn't pass the vertical line test, well, then that's not the graph of a function. So technically, this sideways U is not a function. Well, the way we take care of that is that we say the square root function, which by the way is y equals the square root of x. We say the square root function only uses the top part of the graph. So in other words, we're basically just going to kind of wipe out, in fact, we're just going to basically ignore this whole bottom part of the graph here. So our graph of the square root function is just going to be this top curvy part right here. All right. So I want to talk a little bit about the characteristics of this new graph, this new function that we have here called the square root function. And the characteristics that we're going to talk about are the vertex or the endpoint, domain and range, end behavior, asymptotes, and symmetry. So the vertex or the endpoint of this particular graph, that's this point right here. Now, ordinarily I would have called that a vertex. In fact, if I had my whole graph up here still, then that would have just looked like the vertex on a y equals x squared function. Since I took away the end part, the bottom part here, it doesn't really qualify as a vertex anymore, so I'm just going to call that an endpoint. But that point is just the origin, 0, 0. So that's my endpoint for that graph. Domain and range, and remember domain is the x values that the function can have, and the range is the y values that the function can have. And by looking at my graph, and also by asking myself if I can put up any walls around my function, I can see, yeah, I can put a wall over here on this side. It's going to stop right here when x becomes 0. I can't put a wall up over on this side, though, because I can see my function just keeps going on in this direction. So it doesn't have a wall here. So I can see that I'm only going to have positive values for x. I'm going to have x equals 0, and then I'm going to have all positive values. So my domain is going to be, I'm going to write it as x greater than or equal to 0. So that's all the x values that I can have. X is greater than or equal to 0. My range, I can see, is I can kind of look at it the same way. Now remember range, I asked myself, can I put a floor or a ceiling on my function? And I can see that, yeah, I can put a floor on my function. I can put a floor right here because my function is never going to go below the point where y equals 0. However, if I try to put a ceiling on my function, I can see that's not going to work because it's just going to keep going up, and whatever ceiling I try to put on it, it's always going to break through it. So my range, it looks like, is only going to be these positive values for y along with y equals 0. So my range is also going to be y greater than or equal to 0. Now the end behavior of a function. End behavior of a function, in this case, we're just going to be interested in what happens to the function as x gets larger and larger and larger and larger and larger. When I say what happens to the function, I'm essentially asking, well, what happens to y? What happens to the y values as x keeps getting larger and larger? And the way we typically write this is we say, as x approaches infinity, that is, as x just keeps getting larger and larger and larger and larger, what happens to the y values? Well, I can see on my graph, as x keeps getting larger and larger and larger, my y values also keep getting larger and larger and larger. They keep going up and up and up. So I will say, as x approaches infinity, y also approaches infinity. X keeps getting larger and larger this way. Y keeps getting larger and larger in the positive y direction. So as x approaches infinity, y approaches infinity, and we call that the end behavior of the function. Now, asymptotes, turns out this function does not have any asymptotes. We're going to talk a little bit more about asymptotes a little bit later, but for now we're just going to note that this function does not have any asymptotes. Some functions have asymptotes and some don't, and this one, it turns out, does not have any asymptotes. Symmetry, remember, symmetry is there some way that I can draw a line somewhere that I could divide it into mirror images? And this one, when I had the bottom part of the graph on here, I could have said it had symmetry. But since I got rid of the bottom part of my graph here, I've just got this one curvy piece of it. This function, this graph, doesn't have any symmetry. So again, I'm going to say, no, it does not have any symmetry.